Greetings, everybody. Welcome to the second day of volume. The first day we worked on just applying some of the volume formulas that we discovered through that GeoGebra explanation, and also through some of the examples. We gave you the formulas, and you just had to learn how to apply the formulas. So let's start today, kind of picking up where we left off with a couple application questions, and then we're going to find the volume of some composite figures. Composite figures implies that there's more than one figure put together. So we'll have to add volumes together or subtract them in some cases. So that's what's coming. We have one more day after this lesson today. Our next day will be a little quiz over volume, and that'll really conclude things, boys and girls, as we kind of wrap up the school year after that. So this is the final stretch. Let's finish strong. So here we go. Number 2 is the first example we're going to do. We're given the volume of this cone right here, 150 cubic centimeters, and we want to figure out the radius. All right, so first thing, no matter what, is write down the formula. Volume of a cone is 1/3 pi r squared h. Let's plug in what we know. We know that the volume is 150, so we're going to plug that in for v. 1/3. It tells us to use, it doesn't tell us what to do for pi, so let's just leave it pi for now. We don't know what the radius is, that's what we have to find, and we know the height is 9. All right, so what can we do here on the right side of this equation? What we can do is we can combine 1/3 times pi times 9. Let's do that and figure out what that's going to give us. What that gives us is 9.42 r squared. Okay, so now we have a two-step equation. First, we need to get rid of 9.42. So we'll divide both sides by 9.42 to cancel that out. 150 divided by 9.42 gives us about 15.91 equals r squared. And then if r squared is that, we need to square root 15.91 to figure out what r is. And if we do that, we get just about 4, approximately 4 is what I'm going to say. So the radius is approximately 4. On the calculator for me it says 3.99, but we'll round that up to 4 for the radius of that cone. Next we'll do number 3, and we will come to the left side of number 3 to work this one out. We have a quarter and we're spinning the quarter. We want to figure out the volume, and the shape that it's going to create is a sphere. When we spin that circle, it would create a sphere. How much space does it occupy? So we have to figure out the volume. That's what that means. We want to use 3.14 for pi. Let's write down the formula. For a sphere, it's 4/3 pi r cubed. Let's plug in what we know. So the volume is what we're trying to find, equals 4/3 times, they tell us to use 3.14 for pi, times r cubed. Well, what is the radius? It tells us the diameter right there, but the diameter is double the radius, or in other words, the radius is half of the diameter. So let's take 0.995 and let's divide it by 2 to figure out the radius. So my radius is really 0.4975. Okay. And that's cubed. Okay, so now all I have to do, boys and girls, is I have to just take all this and plug it in my calculator all at once, okay? And here's how you do that. On your calculator, you would type in 4ABC3 if you have a TI-30, or you could just do 4 divided by 3 equals, and then continue on with your calculation. So 4/3 times 3.14 times 0.4975 raised to that's the caret button, raised to the 3rd power. For the volume, I get 0.515, and that is inches cubed for the volume. So that is my volume of that quarter. Next problem I want to check out here is number 5, and here is a composite figure. A composite figure, again, is a figure that's formed of two figures put together. So here we have a cone, and then we have a sphere, or a hemisphere, really half of a sphere, on top of that cone. We have to find the total volume. So let's write down our two formulas that we're going to need to use here. So the total is going to be the volume of the cone plus the volume of the hemisphere. So that means that what we need to use is 1/3 pi r squared h for the cone. And then for the hemisphere, usually we would do 4/3 pi r cubed, but a hemisphere is half of that. So we just want half of that because a hemisphere is half of a sphere. All right, so now we're going to plug in the information we have. First, focused on the cone. All right, so 1/3 pi. What's the radius of the cone? The radius of the cone. So the diameter is 6, which means the radius is 3. So we're going to plug in 3. And the height of the cone is right here. It's 8. Okay, now I'm going to keep going. Plus 1/2 parenthesis 4/3 pi. What's the radius of the hemisphere? Well, it's the same as the radius of the cone. So the diameter of it is 6. The radius is again going to be 3. All right, so there is my calculation. Now I'm going to calculate each part individually here. When I type in this part in my calculator, I get 75.4 approximately, 75.4. Now I'm going to type in the second part. I'm going to type that in my calculator and write down what I get. And when I do that, I type in 4 ABC3 times the pi, there's a pi button, times 3 caret 3, and then I multiply whatever I get for that by 1/2 or 0.5. And what I get is 56.55 approximately. I'm going to add these two together to get my total volume. And my final answer is 131.9 approximately, and that's feet cubed, cubic feet. So there's our composite figure where we had to add together the volume of a cone and the volume of a hemisphere, and we got 131.9 cubic feet. Let's check out one more, number 6. Now here we have an even more complex situation. We have a cylinder, we have a cone, but then we have a hollow cylinder in the middle of the big cylinder. So we're going to have to take the volume of the cylinder plus the volume of the cone minus the volume of the small cylinder. And that's going to give us the total volume there. Now remember, because this is a hollow little cylinder here, there's no volume in there, okay? That's why we're subtracting it out. It's inside of the big one, so that's why we're subtracting it out. All right, so let's write down our formulas here. Volume of the cylinder is pi r squared h. Volume of the cone is 1/3 pi r squared h minus volume of the small cylinder. So cylinder is still pi r squared h, but our radius will be different for the small cylinder than it is for the big cylinder. All right, let's continue. First, we're going to focus on the big cylinder right here. What's the radius of it? Well, we know the diameter of it's 12, so the radius is going to be half, so 6. So we have pi times 6 squared. And what's the height? The height is 17 for the cylinder, and it's going to be the same for both cylinders. So times 17. All right, plus 1/3 pi rh, or pi r squared h. Now we're focused on the cone though. The radius of the cone is still the same, it's still 6, and the height of the cone is given right here, it's 9. So 6 squared and then 9. Okay, lastly, the small cylinder. The small cylinder would be pi. The radius of the small cylinder is right there, it's 3. So 3 squared, and the height of the small cylinder is still the same as the large one, it's 17. All right, so that was the hard part. Now I just got to plug each piece individually in my calculator. I'm going to plug that in, I'm going to plug that in, and I'm going to plug that in, and then I'm going to put them together. So here we go. When I plug each of these individually in my calculator, I get the results that I wrote out right here. There's the volume of the big cylinder, here is the volume of the cone, and here's the volume of the small cylinder. Now I'm going to combine those numbers. And when I do that, I get 1,781.3 cubic inches. So there's my total volume of that composite figure that was made up of 3 figures, a big cylinder, a small cylinder, and a cone. Okay, that's it for our lesson today. Continue working on the practice that I post on Schoology. There's a couple more questions I want you to do on that, and that will help prepare you for the quiz that's coming in a couple of days here on Wednesday. All right, be well, everybody. See you next time.